Okay, today we'll briefly go over an example of molecular and empirical formulas. And what we had done in class is, remember, if you are given percentages of what maybe a mass spectrometer breaks down what's in a compound, what you would do is mathematically calculate the simplest whole number ratios for that, and that is your empirical formula. And also what happen is it will also give the atomic mass of that substance. It doesn't give you the breakdown of each element in its assorted quantity as far as what the formula is. That's why you would mathematically calculate that. So here is an example. If found that there's 40.92% carbon, okay, we just change that to grams. Okay, then the next substance is 4.58% hydrogen. Oops, we changed that to the percentage to grams like we just said. Okay, so that's grams of hydrogen. Then if we were to say the rest was oxygen, what you would do is add them two together and then subtract from 100, which would be fairly difficult to do in your head because the rest is oxygen. It would be fairly difficult to do that in your head. 42.2, okay, plus 4.58, and we subtract that from 100 and gives us 53.22, okay, percent oxygen. So 53.22% or grams of oxygen. Okay, so we know that the breakdown of this substance is carbon, hydrogen, and oxygen. And when we do that, maybe that's a sugar, okay? Maybe that's a carbohydrate of some sort. Maybe it's a vitamin. Could be any one of those. So what you do then is mathematically calculate the whole number ratio for this. Since this is what's found within the compound, we go ahead and what do you think we would do next? Maybe I'll just go ahead and hit pause for just a moment and then see if you know what it is that you would do next. Okay, so if you said take these substances and convert them to moles, that would be correct, okay? Because I see we're already up to about 2.5 minutes. So again, the goal is to try to keep them somewhere around 15. That might be fairly difficult to do, but nonetheless, we'll still try. Okay, for every mole of carbon, you get 12.01 grams of carbon. And when it comes to hydrogen, for every mole of hydrogen, okay, you get 1.01 grams of hydrogen. And then finally, for every mole of oxygen, you get 16 grams of oxygen. So in each and every step, we're going to convert these to moles. Okay, so 42.2 divided by 12.01, that gives us 3.51. So we've got 3.51 mole of carbon, and then this is probably somewhere around, what, maybe 4.5, pretty close to that. 4.58 divided by 1.01, that gives us 4.53 mole of hydrogen. And then finally the remaining oxygen, 53.22 divided by 16, and then that gives us 3.33 mole of oxygen. Okay, so notice that those are pretty close to one another. It's when we get to this step, you need to find the smallest number. In that case, it's this one, and divide them into each other. So 3.33, okay, that gives us 1. 3.33, 4.53. Divided by 3.33, that gives us 1.36. Okay, And then with this one, 3.33. Okay. That gives us 1.05. Okay. So with that, notice we have about 1 1/3 is what we have here. We can't leave this as 1 atom of carbon, 1 atom of oxygen, and then 1.36 atoms of hydrogen. So since we have 1 1/3, we go ahead and multiply that by 3, which then gives us 1.13 times 3. Okay, that gives us 6, I believe. 1.36 times 3. Oh, I was way off. 4. Okay, actually 4.08. And then this would also give us 3. Okay, we multiply everything by 3. So with that, what we would also see if we needed to calculate the molecular formula, because again, these come in very different types of ratios, whether it could be glucose, sucrose, and many of them carbohydrates just have a ratio of 1 to 2 to 1. That isn't quite what we have here, but nonetheless, we would write C3H4O3, but then in order to calculate, is this the correct molecular formula, you would have to be given the atomic mass, and in this case, it's 176. Okay. So in this case, how we did it in class was X equals, okay, 176. That's the atomic mass of this unknown substance that we've had. We've calculated the empirical formula, so we're going to put that mass down here. And if it comes out to be 176, well then the empirical formula and the molecular formula would be the same. So 12.01 times 3. Okay, that gives us 36. Let's go ahead and write that over here, 36.03. Okay, carbon's atomic mass times 3 is where that number comes from. Then we've got, okay, 1.04 times 4, 4.04. And then finally oxygen, 3 times 16 would give us 48. Okay, then upon adding all those together, oops, not 64, 48. Oh, how did I hit that button? Took the, the log of all that. 36.03 plus 4.04 plus 48. That then gives us 88.07. And again, that is the empirical formula mass that we have. So this is the given molar mass of the substance. So 176 divided by 88.07. That gives us 1.99, which is X equals 2. So therefore, everything here has to be multiplied by 2. Or you could say C6H8O6 would be your molecular formula for that. So that was a brief way of looking at how we calculate empirical and molecular formulas. Then the last thing I'll do is, I see we're about at 9 minutes, is we'll just go ahead and calculate, well, for this substance, which is actually vitamin C or ascorbic acid. I think this problem does look familiar, whether it was one of your problem quiz evaluations or something to that effect. So we'll just go ahead and take the first one of this. If we had a 15-gram sample of this substance, which again is vitamin C or ascorbic acid, how much of that is carbon? Okay, so we can get rid of all of this. But here we got to be careful because we're going to use the molecular formula for that. So then we're not going to be using 3 because that 2 has to be distributed, so we'll be using 6. So if we had 16, what did I say, 15? Yeah, 15 grams of vitamin C, I'll just put vitamin C here, or ascorbic acid. How much of that is carbon? Okay, so upon doing this, we would have to have the atomic mass of all of that, which I believe would be 176 because we just did that portion for this compound. So the molar mass of vitamin C is 176 grams per mole. Okay, so grams per mole. Remember, this is interchangeable, so you can cancel out your factors. Okay, so those are now gone. We're in moles of vitamin C, and again, this is what's really, really important is this third step. Step 1, step 2. This third step allows us to change what it is that we have, which is this entire substance, mole of vitamin C, into moles of what we're looking for, which is just carbon. Okay, so now we got to look back at our formula, and we put 6 moles of carbon. I understand there's 3, but from our molecular formula, that got distributed through, so 2 times 3 would give you that 6. That's where that 6 is coming from. So now for every mole of carbon, you get 12.01 grams of carbon. Those are now gone. All our factors are gone except for grams of carbon, because that's what we are looking for. So we take 15 times 6 times 12.01. Okay, 15 times 6 times 12.01. That gives us 1080.90. 1080.90. We still have that 176 to contend with. So we'll go ahead and take a look at that. Divided by 176. That gives us 6.14 grams of carbon. So for ascorbic acid, or vitamin C, in this context, if we had a 15-gram pill, 6.14 grams of that is carbon. So if we wanted to know the percent composition of this, we could also take that one step further, divide 6.14 divided by what we started with. So then the percentage of that then, 6.14 divided by 15, and it is 41%. Okay, so that was a brief overview of empirical and molecular formulas. Remember, you have to do the empirical formula first, then see if that atomic mass adds up to your given substance, which was this here. So C3H4O3 added up was 88. You divide that into this. That's where this 2 comes from. Then we went ahead and did the molar mass for this and said for a 15-gram pill of ascorbic acid, okay, that's going to give us 6.14 grams of carbon. Then if we want to know the percent composition, that 6.14 is divided by what we started with. Okay, so we're right at about 14 minutes, which is a good place to stop. Hopefully we're all together tomorrow again, so if you have any questions, you can do that in real time. This is the best way we can get this information passed on to yourself, and then as we're aware, this semester is winding down. So we'll catch up to you next time.